Hello, in this session we'll see another question based on fitting of straight line. So the question is as such, it says fit the straight line for the given data. Which is as such. So for the given question and the given data, we'll start with the general equation of the straight line, and let us say that is y equal to a plus bx, and the normal equation will be given as summation y equal to n times of a plus b times of summation of x, and summation xy equal to a times of summation of x plus b times of summation of x square. So for this we need to find summation of x, summation of xy, summation of x square, and summation of y. Now starting with the data which is provided here, let us make some observation. Now let us take down all the values, that is 100, 120, 140, 160, 180 and 200. The y values are 0.45, 0.55, 0.6, 0.7, 0.8 and 0.85. Apart from this, we can see that x values are very large, and also there is a possibility of taking one of the value as assumed mean, and let us say that we take 140 as the assumed mean in this case. So in that case, taking 140 as a, forming a table which will have the deviation di as x minus a, that is x minus 140. So table containing the column di will be 0, 120 minus 140 will be minus 20, this is minus 40, 160 minus 140 will be 20, 40 and 60. Now apart from this, we can again observe that this di, the deviation, is having a common factor, and that is 20. So let us make another observation, and that is considering ui as di over 20, which can also be written as x minus 140 over 20, x in the sense xi. So the simple expression, that is di over 20 is ui, will become minus 2, minus 1, 0, 1, 2 and 3. Now let us form the table column, that is ui square. So minus 2 square will be 4, minus 1 square will be 1, 0 square will be 0, 1 square will be 1, 2 square will be 4 and 3 square will be 9. Apart from that, the column containing u times of y. So u times of y, so that is 0.4 times of minus 2 will be minus of 0.9, 0.5 times of minus 1, 0.55 times of minus 1 will be minus of 0.55, this will be 0, 0.7 times of 1, 0.8 times of 2 and 0.85 times of 3, that is 2.55. Now looking for the total, this will be, the sum of u will be equal to 3, the sum of ui square will be equal to 19, the sum of uy will be equal to 3.4, and that is all we need here. So with this information, coming back to the normal equation, in terms of y and u, we will have summation of y equal to n times of, let's say, a naught, where we are forming the equation y equal to a naught plus a1 times of u. So n times of a naught plus a1 times of summation of u, summation of uy equal to a naught times of summation of u plus a1 times of summation of u square. So this is the normal equation will be used here to form the equation y equal to a naught plus a1 times of u. Now we have found all the summations value and we'll just put it there, and that is going to be summation of y will be 3.95, which will be required here. So the equation formed is 3.95 equal to n. So what is n here? We can clearly observe that n is the number of data we have. So that is 1, 2, 3, 4, 5 and 6. So n is equal to 6. Now with this n equal to 6, we can continue with the equation, that is 3.95 times equal to 6 times of a naught plus summation of u, which is 3. So this is 3 times of a1. Summation of uy, this is 3.4 equal to 3 times of a naught plus 19 times of a1, and that is the value of summation of u square. So this is the set of simultaneous equation. This is the set of simultaneous equation which we'll get, and with this we can try to find the value of a naught and a1 to find the straight line equation. So using Kramer's rule, del will be 6, 3, 3, 19. Del 1 will be 3.95, 3.4, 3 and 19, and del 2 will be 6, 3, 3.95 and 3.4. So del 1 and del 2 is obtained by replacing the column 1 with the coefficients, and del 2 is obtained by replacing column 2 with the coefficients. So in that manner, now we have to calculate the del 1 and del 2. This is 105, this is 64.8, and this is 8.55. Now using the Kramer's rule, the value of a1 and a naught can be found, and a naught will be del 1 over del, which will be equal to 64.8 over 105, which is equal to 0.6176. E naught will be del 2 over del, and that will be 8.55 over 105, which will be equal to 0.0814. Now with this value of a naught and a1, the equation of straight line in terms of u will be y equal to 0.6176 plus 0.0814 times of a1 plus 0.0814 times of u. Now in our knowledge, we have already said that u is x minus 140 over 20. So with the relation that u is x minus 140 over 20, just substituting that value here, we'll have 0.6176 plus 0.0814 times of x minus 140 over 20, which will become y equal to 0.0478 plus 0.004x. So this is the straight line equation we are looking from the given data, and we have already found it. Thank you.